Hello everyone, welcome to the Advanced Logging with Fluent Bit session at KubeCon 2020 Europe. My name is Eduardo Silva, and together with Wesley Pettit from Amazon, we're Fluent Bit maintainers, we're going to deep dive into Fluent Bit internals, how it solves the logging problems, and everything that you were waiting for. The main thing about logging is have the capability to perform data analysis. But to perform data analysis, you need to collect the data and maybe centralize them in one place. A common use case is to have a hardware or a piece of software that delivers some message, some record, some log, and then centralize this information like in a database or a cloud service. So then you can perform your own data analysis. But when the data starts to scaling up, also we need to scale up our logging pipeline, we need to scale up our aggregation layer, and also the analysis get affected by this because now you have more data to process, and sometimes timing performance is really important for any business. And also there are many challenges with this because data comes from different places. Sometimes we can collect login information or metrics from network endpoints, from TCP, UDP, from the file system, from the local machine, or also through services like Systemd or others. And before we can do data analysis, we need to, of course, take this data out from the source, right? Convert this data from maybe unstructured format to a structured format, perform data enrichment, because sometimes we need to add some context to this data to finally be able to deliver this data to a destination, like a cloud service or your fancy database. And if we think about Kubernetes, the scenario is more complex. Kubernetes is a distributed environment. Your application lives in a pod, and that pod is not alone in a node. It can have many pods together, and a cluster can have many nodes. So if your application is just in one pod or maybe it's on different replicas, how do you correlate all this information back together in a database so you can do data analysis? And that is one of the complexities of this. A common workflow for logging, imagine that you have like a YAML file which you have just one container. This container is reading data to the standard output or standard error interface. Okay, so as an example, I have a YAML file on the left, which is called Apache logs, that just generate random Apache logs messages. And at the end, you get to some raw messages like the one that you have at the right, with an IP address, a timestamp, and the whole message from the HTTP protocol. But in Kubernetes or any containerized environment, that message that was generated by the container is redirected most of the time to the file system. Sometimes handled by journald in a different way. But by default, it goes to the file system, to a container identification that has the pod name, the namespace, in a normal log file that also not only contain the message, but that message also comes with a bit of more context. For example, the original message is encapsulated in a JSON, and this JSON gets the log, the stream name, and the timestamp. Then this information is not enough because we are missing the context, and the context is where this data was generated from, which node, which host, do we have any labels, do we have any annotations that comes from any specific context. So this information alone is not useful enough. We need to correlate all this information together. And because at the end, with this information, and then we want to have something more complete, like this, where we have all the Kubernetes context, we have the message, for example, we have the host where this data was generated from, the container name, the Docker ID, because all this information is relevant for us to be able to perform data analysis once we centralize the data in our database. And that is one of the solutions, Fluent Bit. Fluent Bit is a log processor that is part of the Fluentd family. We are proud to say that Fluent Bit is a CNCF sub-project under the umbrella of Fluentd, and of course, a fully Apache license. It was created in 2015, originally for embedded Linux, but then it quickly evolved for the cloud space. and nowadays it's almost everywhere. It's written in C language, and that's one of the main reasons, because it has a very low memory and CPU footprint. It has a pluggable architecture. We have more than 60 plugins available made by the community, and these plugins allows us to collect data from different sources, to filter data or send data out to different destinations. And Fluent Bit internally is like a pipeline. You can consider that the data comes from an input. You can parse the data, filter the data, buffer the data to finally send its data out to a cloud service or your database. So the whole point about logging is to take data from point A to point B, but in the middle, do data transformation and apply all your logic that is necessary. In Kubernetes, likely you deploy Fluent Bit as a daemon set, but also you can deploy it as a sidecar. But here in the example, we deploy Fluent Bit as a daemon set running in the node, where it's able to collect all the logs from the node to finally correlate all this information back with the API server, where you can get information like labels, annotations. So your final record can have all the information that is necessary for the data analysis. We're going to run a pretty quickly demo to see how this works. I'm going to share my screen. I started the recording. I'm going to start the demo in 3, 2, 1, 2. Here in the terminal, the demo that we're going to do, it's a pretty basic demo. Basically, on my left pane, I'm running Minikube, and on the right one, I'm going to run in my local machine Fluent Bit. But this time, Fluent Bit, which is run on the right pane, is basically will work as an aggregator, collect any message that comes from any cluster, right? Process it, reformat to JSON, and print it out to the standard output. So the first thing that we're going to do here in Minikube in the left pane is to deploy a simple Apache logs application, same as we did in the presentation, which basically just push out random logs looking like an Apache server. So we're going to deploy this pod, and then take a look if it's all good. Yeah, it's already up and running. So we can take a look at the logs of that specific pod and see that it's generating messages in a random way, different IP addresses and messages. I'm going to break it a little bit so we can get the whole messages here. Okay, this is just running locally because we are not shipping out the messages. We're just querying the local instance of Minikube. So what we're going to do now is to deploy Fluent Bit. I just prepared a script to make it shorter, where we ingest the config map, we deploy the daemon set for Minikube, and we just query the status of it. After this deployment, after a few seconds, we will see that in our right pane, the data will start flowing and being formatted in JSON. As you can see, we are getting the data without any problem. I'm going to stop right now. I'm going to delete that pod so we can do a clear analysis on the right side. As you can see, for example, on this record, we have the date, we have the original log, the stream, and the timestamp from that original record. And also we have the whole Kubernetes metadata, which is quite important because we get the pod name, the namespace name, pod ID, labels, host, container name, and so on. And well, the original message is here in the second key, which is called log. Now I'm going to show another feature of Fluent Bit, which support a custom parsing based on label annotations. So I have here the same Apache log container definition, but I'm adding a parser in an annotation. Basically, I'm saying please parse all these records from this container using the Apache parser. And Apache parser is predefined in the Fluent Bit configuration. So as soon as I deploy this, Fluent Bit will get aware of all these our Apache log messages. It will structure them and send it out to my aggregator, which is running on the right side. So we follow the same procedure. And we will see that the data will start flowing on the right side. But now take a look at the output, which is a little bit different. For example, If we take a look at this log, it's pretty much the same. We have the date, the log, the stream, the time, but also now we have, as it's still flowing, a new map which contains the data processed coming from the original log message. So if you go up, you will see that we have the IP address of the host. We have the user, the method, the path that was accessed, the return status code, and the size. This is a unique feature that is provided in Fluent Bit. So for example, if you are sending and running a Golang application, you can say, hey, parse my log messages as Go. Or, well, if you are shipping just JSON messages as log messages from your container, that will be handled right away for you. You don't need to do anything else extra. So this is one of the advantages of using Fluent Bit in Kubernetes, is that it can take all your logs out of it. I'm using another Fluent Bit as an aggregator, just as an example, but you can use Elasticsearch, InfluxDB, AWS Cloud Services, Google Stackdriver, and any of the more than 20 or 30 outputs destination that we support. Okay. Some weeks ago, we released Fluent Bit 1.5, one of the major release of the Fluent Bit era. And it has a lot of improvements and also a lot of contributions from different companies. One of the major changes also in the core is the ability to have a more configurable and reliable networking functions. Before this, Fluent Bit didn't have the option to send data through keep alive connections. Right now you can reuse keep alive connections, you can reuse all your TLS handshakes. So of course you can send data fastest. This was not a need years ago, but nowadays it is, since people is mostly streaming data every second. Also, we have a full Windows support version. And on this version, we have implemented the whole Windows service. So you can run Fluent Bit in Windows like a service. Also, the plugin to collect data from the Windows event log has been highly improved. In addition, now you can run Fluent Bit for Windows on Kubernetes without any problem. We did a couple of improvements. So if you're running Windows with Kubernetes Windows, you can run your pods and collect your logs with Fluent Bit without any major issue. Also, our community has contributed a lot of ways to monitor Fluent Bit. So right now we have in our documentation a couple of examples on how to run your own Grafana dashboards, so you can take advantage of the whole monitoring also from the same pipeline that you are working with. In the part of the storage, we are exposing also metrics to see how the data that is inside the pipeline is flowing, meaning how many chunks of data do I have in memory, how many of them are in the file system, so you can get a notion of how the data is flowing, also how much disk space are you using, and how much memory are you consuming for all your data ingestion and delivery. As part of the enterprise and partnerships that we did, we're happy to say that we have a new connectors, and improved connector, for example, for the Amazon Elasticsearch service. We have a new plugin for the Amazon CloudWatch. Wesley is going to talk more about it. And also new enterprise connector for LogDNA and New Relic services. Also, in the latest months, we have been working with Google to improve the Google Stackdriver connector in Fluent Bit, which is written in C, of course. And we have many improvements to consume Kubernetes resources, special labels, you can append special keys. And nowadays, it's becoming a reliable solution for most of the Google Cloud customers. As an overall status of the project, just on 2020 or half of this year right now, we're hitting more than 100 million deployments. And this is just an insane growth of the project. So every day we have more than 500,000 deployments from different clusters and everywhere in the world. We don't have visibility who or from where. We just know that we are getting all these downloads every day. And of course, this is thanks to the community and the traction that we are getting. And in the enterprise, as I said, the traction, we have many companies using Fluent Bit and suggesting Fluent Bit for the customers. like AWS, Google Cloud, ARM, Sumo Logic, Datadog, LogDNA, and all of them that you can see on these slides. And many more companies that, of course, they use Fluent Bit privately for their own reasons. Now I'm going to pass the control to Wesley, who's going to talk about his great work on the Amazon connectors.
I wish we were all in Amsterdam, but oh well. Anyway, so as Eduardo said, I'm going to be talking about the work that I've done with AWS plugins in Fluent Bit. I am the AWS co-maintainer of Fluent Bit. I maintain the AWS portions of Fluent Bit and generally help out with the project as a whole. So last year, I launched AWS for Fluent Bit, which is the AWS distribution of Fluent Bit. It had Fluent Bit bundled with a couple of external plugins written in Go that supported CloudWatch logs, Kinesis Firehose, and Kinesis streams. So the reason why I wrote those external plugins in Go, the main reason was because so AWS has its own authentication and credential and signing mechanisms. And there's an AWS SDK in Go that supports those. And there was not one in C. Also, in general, Golang supports very fast, rapid development, and so it allowed us to integrate with Fluent Bit very quickly. So as I mentioned, AWS has its own custom, unique signing mechanism that we came up with to fit the scale of AWS. And there are many, many sources that you can have for credentials depending upon where in AWS you're running. And so this was a blocker for me to contribute plugins to the core of Fluent Bit. But new in Fluent Bit 1.5, there is a core library for AWS authentication, signing, and credentials. So basically, last year, Eduardo and I met at KubeCon and then AWS reInvent. We talked, and then I took a long vacation in December. And during that time, I day and night worked writing code to create this library, custom library in Fluent Bit to do authentication and signing. As you saw in the previous slide, it ended up being almost 7,000 lines of code. It was pretty huge, but it's finally now released and it works. And so I'm going to talk about what you can do with it. So the first thing that I did is using that library. I took the Elasticsearch plugin in the core of Fluent Bit, and I added support for Amazon Elasticsearch Service. So Amazon Elasticsearch Service is, it's just a hosted version of Elasticsearch, but it has AWS authentication in front of it. So we needed this library. So as you can see here, there are new fields: AWS auth, AWS region. You also turn TLS on, and one thing I want to note is the port is usually 443 if you're using Amazon Elasticsearch, and for the host, you do not put the protocol. You don't put the HTTPS in there. That's one thing that sometimes people get confused with at first. And then also, we're seeing here, there's also another field, AWS role ARN, that lets you specify a IAM role that it will make an STS assume role call on, and so that you can use an alternate role to put to Elasticsearch. Check out the documentation if you want to learn more about that. Then, so, as I said, last year I created a external plugin in Go for CloudWatch. I rewrote that plugin and contributed it to the core of Fluent Bit in C, which you can see here. This is a configuration for it. It supports all the same options. The only difference is that the name of the plugin is CloudWatch _logs. The old plugin was just CloudWatch. So that is the only difference. Otherwise, you can just very cleanly migrate between the two of them. So this new plugin, because it's in the core of Fluent Bit, it's in C, it is more performant. And it's not just a matter of C being more performant than Go, because Go is really a pretty good language in terms of performance. It's partly that compiling Go and CGO together with a CGO compiler adds some inefficiencies that you wouldn't get with pure C or pure Go. It's also because in Fluent Bit, plugins that are external that are in Go cannot take advantage of the concurrency mechanisms that Fluent Bit has to do asynchronous HTTP requests. But with this new core connector, everything works very flawlessly. So you can see here there's a decent improvement in the CPU usage, but what's really better and really bigger is the change in memory performance. So you're potentially looking at a 3x improvement in memory usage. That's said that the new plugin is using 1/3 of the memory. Even at fairly high load, you could be using less than 50 megabytes of memory. Even at MetGraph, you're seeing 20,000 log lines per second. So that's pretty substantial. We also have seen evidence that the max throughput achievable with this new plugin is significantly higher than the Golang plugin. I had said that I was going to try to quantify that for this talk. Unfortunately, I got busy and I was not able to get hard numbers, but maybe next year in the future talk we'll have more of that. Anyway, so long-term things that I'm thinking of working on. So I want to rewrite all of the Go plugins in C and contribute them to the core of Fluent Bit, so we have everything high performance and centralized in the Fluent Bit code base. Then we can deprecate the Go plugins, alias the names of the old plugins into the C plugins so that you can have a clean migration for all users from the Go plugins to the C plugins. It can be entirely transparent because they support the exact same features. The timeline for all of this is uncertain though, and as I say here, don't quote me on it, like there's no guarantee, but this is what I'm thinking. So also in FluentBit 1.4, I built an EC2 instance metadata filter that adds your instance ID and availability zone to your logs if you want it. I think in the future, maybe we'll expand that. I might also work on an ECS task/service/cluster metadata filter as well. We'll see. And then in terms of outputs, I'm thinking eventually could maybe get all 6 of those things that you see there in the core of Fluent Bit. So all of the existing ones, also Elasticsearch, which we already launched, I'm now working on S3. I'm thinking maybe Amazon Event Bridge might be useful too. I'm not sure. Interested in feedback on that. However you want to send feedback to me, issues or Twitter or whatever. Or the Fluent Slack, but interested in seeing if people would find that useful. So what am I working on right now? So right now I'm working on Amazon S3 output support. There's an issue for it on the Fluent Bit GitHub. Check that out if you have suggestions. Let's see, since it is in August that this talk is being streamed, hopefully that will actually be nearly done by then and will be releasing fairly soon. We'll see. Our plan is sometime in September, hopefully. So I put a lot of thought into the S3 output. So the way that the Fluentd S3 output works is it buffers files locally, and then it uploads them all in one go to S3. And that's okay, but it's not perfect because while you're buffering on disk, there is this risk of data loss, right? If FluentBit goes down or Fluentd goes down, and you lose those files, if you don't have a reliable disk, like maybe you're running in a more ephemeral environment, like a serverless environment, you can't really trust the disk. It doesn't really work. So my goal is to make this S3 plugin be more sort of like a streaming model. So it's going to use multi-part uploads. So the multi-part upload API basically lets you send data in very small chunks to S3. So you can break up a file into pieces and send it in chunks. But the thing is it doesn't require that you actually have all of the file ready when you want to send it. You can, as you get data, stream chunks to S3, and that's what my bad diagram is trying to show with the puzzle pieces going into the bucket, is that as FluentBit is getting data, it's adding a new piece to the bucket. And then once it reaches the file size that you want, it will tell S3 to concatenate those together and create a final file. So basically, the long and the short of it is that you're streaming to S3. You're not buffering more than a few megabytes of data locally at a time. The amount of locally buffered data at any one point in time should be very low, which reduces the chance of any sort of log loss from any sort of interruption, or if Fluent Bit goes down, you have to restart it. So here is an output definition that I'm thinking of. As you can see here, you can set the file size that you want in S3. And remember, note that, like, as I said, it will be streaming and uploading in little chunks, but the final file that you see will be whatever size you pick. You can also specify a timeout, so you can say, like, every 60 minutes, create a new file in S3. I can do that as well. I'm trying to come up with some interesting stuff, some useful things on the key format, where you can maybe have, like, use the parts of the tag. The syntax that you see there was introduced in the rewrite tag filter in Fluent Bit 1.4. I'm thinking of trying to support that in the S3 plugin for the key. Check the documentation to see what I come up with. And if you have suggestions before it launches, please post them in the issue. So, okay, if you are an AWS user and you want to get help with Fluent Bit, how do you go about it? We have really high adoption of Fluent Bit, so we get a lot of questions and issues. The preferred mode is to open an issue on the AWS/AWS for Fluent Bit repo, because I have a bunch of folks at AWS who I have trained to understand Fluent Bit, and we can all work on answering your questions. You can also try to contact me directly via Slack or Twitter, or on the core repo. All of those are fine, but I think outside of GitHub, your guarantee of a response is much slower. I do not respond to people on Twitter faster than a week often. Anyway, so another interesting thing that I want to talk about, this is kind of switching gears. This is moving away from AWS. This is taking off my enterprise hat and putting on my just pure open source hat. Recently, I have been working with the folks at the OpenTelemetry project. So OpenTelemetry is a new CNCF project. It's an incubating project. And its goal is to create a standard set of SDKs and specifications for metrics and traces, and maybe eventually logs too, that basically all of the vendors will support. You can instrument your application with these SDKs that they'll produce, and you won't have to worry about being locked into any sort of a monitoring service, because the SDKs will be supported by everything. So it's a very exciting project. I'm very glad that it exists, and very happy to work with them the little bit that I have. So they have recently started working on defining a log data model, which might become maybe a standard schema for log data, a standard kind of structured model for logs. That's its goal. Definitely, I do feel a little bit conservative about OpenTelemetry because it is an incubating project. We'll have to see if this specification, especially for logs, catches on. It won't really actually be useful unless it's widely adopted and lots of vendors recognize the format. But I want to talk about how this model works, and what it might look like if we supported it in Fluent Bit. So I want to say I talked to the folks who worked on this model, but I can't take any credit for it. It was primarily created by an OpenTelemetry maintainer named Tigran Najarian. I think I got his name correct. I apologize if he's watching and I did not get it. I don't know if if he will be watching this talk. Who knows? I'll try to tell him to watch it. Anyway, okay, so the log data model that they came up with, it has a couple different fields, structured fields. The goal is to standardize structured logging, basically. So structured logging is great because it makes it easier to process and analyze your logs because the data is in a structured format. But the ideal case would be that there's like a standard way to structure them, because if you structure your logs in different ways with different field names, you're still kind of in a bit of a mess. And so that's the goal. So you have a timestamp Unix nanoseconds. You have fields for correlation with traces and spans. You have a standard way to represent severity, a name for the log, like an event name. You have a body, which is for unstructured, not machine readable, but human readable data. You have attributes, which are for structured, like key value pairs that might be machine readable. And part of the goal of this schema is to eventually create standard key names for basically any type of data that you might want to put in there. So, I don't know, like Kubernetes metadata, IP address, like there'll be a standard field name that you always use for whatever metadata that you're adding to your logs. And then the resource, that's actually where the Kubernetes metadata would go. It would be a standard way to, with key value pairs, represent where a log came from. So here's an example log. So as you can see here, there's the timestamp. Then there's a set of attributes. Like I said, these are key value pairs. The idea is eventually to have very clearly defined semantic conventions for how you name those key pairs so that they are really uniform across all of your applications. Then you have the resource, which is where the log came from. Again, same thing. Eventually, we want to create a very standard way of naming all of those things. And then we have a couple more fields. So we have a severity, which has both a text description and a numerical description. And then that's about it. So what would it look like to support this in Fluent Bit? So this is something that we're thinking about. We probably won't do it until later this year or maybe the beginning of next year, because OpenTelemetry, like I said, it's incubating. It's extremely new. This log data model was just created. I don't think it's really been adopted or used by anybody yet. So basically, the Kubernetes filter or the EC2 metadata filter, anything that adds metadata for where a log came from, you'd want to add that to the resource. In our tail plugin in Fluent Bit, normally we encase a raw log message in a key called log. That instead would be the body field because it's for unstructured data. If you parse that data, it would then become part of the attributes. So that's how it would kind of work. So if we decide to support this in Fluent Bit and it catches on, it's actually not a lot of work. I think Eduardo and I can get it done quite quickly, and that's exciting. Though in some ways, really, for this OpenTelemetry log data model to catch on and really be useful, it's more about logging in your application, and that's something that OpenTelemetry eventually wants to do is integrate with existing logging libraries. Anyway, so finally, switching gears again, before we end this session and go to Q&A, if you want to learn how to contribute to Fluent Bit, if you have some basic knowledge of how to write code in C, but you want to know how Fluent Bit C code works, I wrote a whole entire guide to that in the repo. Check that out. Alrighty, so now we will go to Q&A. Please ask any questions that you have for Eduardo and I. Thank you, everyone.
Hello, hello. Okay, so we have a question coming from David asking if the Lua filter will support modifying tags. Not at the moment, but feel free to open an enhancement request. But we have also other ways to retag. Sorry, looks like I was muted. Sorry about that. So we have a question from David Beck. Will the Lua filter support modifying tags? Not at the moment, but we have other ways to create records with the tags. With custom tags, rewrite filter, the stream processing. Wesley, you want to jump into the next one?
Which one is the next one? Read it out for me.
Newest. We're doing some kind of random.
Okay, I'm seeing. Are the slides available somewhere? I don't actually know the answer to that. That is a good question for the. I believe we have somebody from the CNCF here. Jennifer?
Yeah, I
Okay.
think that she's not in the process at the moment. So I think that the slides should be available
Yeah.
later.
So I see. Okay. So she's not here on audio. Um, I do know. I'm not sure if this was related or will help, but I know that afterwards, for a few minutes at least, we will be available in the 2-KubeCon maintainer uh, channel in the CNCF Slack, and you can ask us questions there. Um, maybe we'll have an answer there for that. Okay, so next I'm thinking, can it be used as an exporter for Prometheus? The answer is no. I mean, Fluent Bit is for logs, Prometheus is for metrics, unless I'm missing something. I don't. Not sure that would.
Yeah, we expose a matrix for Prometheus, but no,
Oh, I
we
see.
don't ship the Prometheus. Yeah.
Yeah.
Oh,
So you
audience,
can.
just one thing.
Yeah.
Before we forget the Wesley, we have 100 people. And so basically we have a demo on this presentation that for some, we got a technical issue. So if you watch, not again, but if you watch the presentation again around minute 5, you will get a demo about Fluent Bit. So watch on demand in a couple of hours and that will be available.
Okay. Yeah, and that demo I believe shows using Prometheus to monitor Fluent Bit, right? Does it?
No, it doesn't. It's mostly
Okay.
about
Well.
the pipeline.
Oh well. um, okay. Well, but that definitely works. And there's also a built-in Grafana dashboard that the community created recently. So go check that out. That's in the repo.
We have a
Eduardo,
question about limits.
go ahead.
So, Marcus Fermin, thinking about production environment, is there any requirement tip for a Fluent Bit pod in terms of resource requests or limits? Well, it depends on your load, but I think that most of people deploy using 200 megabytes as a maximum. But in general, you don't need more than 50 megabytes. But I think that Wesley can add more details on that.
Yeah, it depends upon your exact level of usage and the plugin you're using. Like I mentioned with the plugins that I built, if you're using the older Golang versions, something maybe more like 100 megabytes of memory is probably a good, safe number. I'd probably still actually stick with something in a range of 100, 150. But with most of the plugins, the ones that are in the core that are in C, you really should they shouldn't be using more than 50. Unless you're just getting extremely high load. Okay, so we're being told, this is on the question of where are the slides. The slides can be found in Sketch, like the word schedule. But so I actually don't know what that means. I've done a bad job of paying attention to how the KubeCon virtual works, but hopefully you guys will all in the audience will know.
Do you recommend set CPU memory limits while deploying Fluent Bit as Demon said? Yes, for anything that is running Kubernetes, you have to set a limit, right? Best practice.
Yeah. I'm seeing, can Fluent Bit buffer logs if the target host, for example, Elasticsearch, is unreachable for a while? Yes, that is true. It has buffering capabilities, same as Fluentd. It works a little bit differently. If you Google for Fluent Bit buffering, there's a whole section in the documentation that goes over it. I'm being told that we only have a few minutes left. Maybe let's both.
There's one AWS question, Wesley. There.
Yeah. Okay. Which one? Read it to me.
Yeah, using AWS Fluent Bit image with AWS Fargate doesn't allow including more config files. Are there any plans to support more flexible configuration with AWS Firelines?
Yes. Okay. So this is not really honestly a Fluent Bit question, but I'll still answer it anyway. I am also the creator of Firelines. In addition to being the AWS Fluent Bit maintainer, I basically do container logging at AWS. That's my specialty. We are working on that. We want to build some sort of better config mechanism in AWS Fargate for Fluent Bit. I cannot really, I'm not at liberty, especially in this talk at KubeCon, to promise any sort of timeline on that though. But AWS has a public GitHub roadmap, and you can go check that out and annoy us and beg for things there. So please do that. We love it. We don't find it annoying.
Community, let's jump into Slack, because I think that we are out of time at the moment. So thanks so much for joining this session. And as I said, we will have the demo available in a few hours if you want to rewatch this on demand. Thank you so much and enjoy the conference.